Hello everyone. In this video lecture, we are going to discuss on machine learning concepts for cyber security. So, why machine learning is important in cyber security? We are going to discuss. Like the first thing is introduction. So, cyber security nowadays, cyber security has evolved in every field. Like before earlier, the mostly it is very it does the task of simple and predictable things like viruses or unauthorized access attempts. So, traditional security mechanisms like firewalls, antivirus softwares, and rule based intrusion detection systems were sufficient because the attacks will follow a similar pattern. But due to this modern digital era, the cyber attacks have become highly sophisticated, automated, and intelligent. So, these attacks now use such ransomwares, fireless malwares, zero-day attacks, and advanced persistent threats. So, where these attacks will remain hidden inside systems for months without detection. So, the main thing is the limitation of traditional security solution is it just depends only on the rules and known signatures. These systems only detect threats which already been identified and documented. But what about the new things like traditional new attacks? The traditional tools fail because they do not have matching signatures. Further, the network will generate volumes of data every second, and which includes logs, packets, user activities, and application events. But the human analyst and manual processing can't help people to make automate the process. Hence this machine learning, so hence machine learning becomes crucial in the context because it enables systems to learn directly from data rather than relying on fixed rules. So ML based security systems analyze patterns of normal behavior which used to detect deviations that may indicate malicious activity. Okay, and instead of asking, is this is a known attack, the ML will do, does this behavior look abnormal or suspicious? So this shift is the reactive security solutions that is from proactive to predictive defense is the key reason why machine learning is becoming an important in cyber security. Now we will see what what is machine learning in cybersecurity. The machine learning in cybersecurity refers to the application of algorithms which can automatically learn from patterns, relationships, and behaviors from security related data. So the data may include like network logs, system calls, authentication records, user logs, and application events. But traditional solutions like it will be only based on rules or explicitly written by humans, but machine learning systems learn these rules automatically by analyzing historical data. The primary objective of ML is to classify. Okay, so it is classify, detect, and predict security threats. So classification, so what is meant by classification? The classification involves identifying whether an activity is normal or malicious. So detection involves discovering suspicious behavior, when the prediction aims to anticipate future attacks, which is based on observed trends. For example, an ML model can learn the normal login behavior of users and detect anomalies such as logins at unusual times or from unknown locations. And another important work with machine learning is its ability to detect previously unseen attacks. Since machine learning models focus on behaviors rather than exact signatures, this machine learning also used to detect zero-day attacks and sophisticated intrusions. So, as a result, machine learning acts as an intelligent layer that continuously observes and adapts to evolving situation. So, now we will see what is supervised learning plays a role in cybersecurity. In supervised learning, a machine learning approach, models are trained using labeled data sets. So labeled data sets means you are learning from a teacher, means the things already known. In cybersecurity, labeled data means like instead is tagged either as malicious or benign. So it is labeled. It is a malicious act and it is a benign act. Like example further, I can tell you, a dataset may contain network packets which are labeled as attack traffic or normal traffic, or files are labeled as malware or legitimate software. The model learns by associating input features with their corresponding labels. So supervised learning will provide you the applications like malware classification, spam filtering, phishing email detection, and intrusion detection systems. Whereas in malware detection, you may check for file size, opcode sequences, API calls, and permissions are extracted from files, whether like that. The model learns patterns from differentiate malicious software from legitimate programs. Once it is trained, the model can classify new and unseen files with high accuracy. However, the supervised learning has challenges in cybersecurity. The major limitations of supervised learning in cybersecurity is it will work only for labeled data. So, labeling security data requires expert knowledge and in both time consuming and expensive. Moreover, supervised models perform poorly when they encounter new attacks. And despite these limitations, supervised learning remains an important foundation for many security solutions due to its high accuracy on known threats. Whereas in unsupervised learning, so unsupervised learning differs from supervised learning in that it does not require labeled data. This is particularly useful in cybersecurity because many attacks are unknown and labeling are not possible, and it is impossible. So unsupervised algorithms, what it will do, it will have some hidden structures, clusters or patterns without prior knowledge of attack labels. So in security applications, unsupervised learning is a primary thing to use anomaly detection. The model learns from normal behavior, looks like observing regular network activities. So any significant deviations from this learned normal pattern is flagged, and the security threat has been initiated. So this approach is effective for detecting insider threats, botnet communications, and stealthy attacks that operate slow to avoid detection. So another advantage of unsupervised learning is its ability to adapt to new environments. Since it does not depend on labeled attack data, it can be deployed in new networks or systems with minimal prior information. However, one challenge is it is that not anomalies are, that it not anomalies or attacks. Some unusual behaviors may be legitimate, so which can lead to false alarms. So unsupervised learning remains a powerful tool for detecting unknown and emerging threats. And we will also see what is semi-supervised learning in cybersecurity. The semi-supervised learning in cybersecurity combines elements of both supervised and unsupervised learning. It uses small amount of labeled data along with a large volume of unlabeled data to train the model. So this approach is tightly relevant in cybersecurity because labeled attack data is scarce. So while unlabeled operational data is abundant. In typical semi-supervised setup, the model first learns general patterns from unlabeled data, such as normal attack behavior. It then uses labeled data to fine-tune its understanding of malicious activities. So this allows the model to achieve better detection, perform purely unsupervised methods while reducing the dependency on large data sets. So semi-supervised learning is particularly useful in enterprise networks, cloud environments, and large scale systems where data volume is high and attack patterns change frequently. It provides a practical balance between accuracy and feasibility, making it promising for the real world cybersecurity deployments. So next thing is reinforcement. Learning. Like as we already saw, semi-supervised learning provides things. And reinforcement learning in cybersecurity, it is a learning paradigm where an agent interacts with an environment and learns optimal activities through feedbacks in the form of rewards and penalties. Unlike supervised learning, reinforcement learning does not rely on labeled data sets. Instead, it focuses on learning strategies that maximize long-term rewards. So, in cybersecurity, learning is explored for dynamic and adaptive defense mechanisms. So, for example, an RL-based firewall can learn with traffic which traffic patterns blocks or allow based on their activity and security. So similarly, reinforcement learning can be used for automated intrusion response, where the system decides how to react to detect threats in real time. And this reinforcement learning is still in early stage in cybersecurity. It has significant potential. It enables the development of autonomous security systems that continuously adapt to changing attack strategies. But challenges are like training complexity, exploration risk, and safety concerns must be carefully addressed before widespread adaptations. Next is feature engineering. So, feature engineering is one of the most critical aspects of applying machine learning of cybersecurity. So, features are measurable attributes where it extracts from raw data, where the model distinguishes between normal and malicious behavior. The quality of a feature directly influences the performance of the ML model. So, security features can be categorized into network features, host based features, and behavioral features. So network features include packet size, protocol type, source and destination ports, and traffic flow and statistics. Host-based features include CPU usages, memory access patterns, and files, everything. Behavioral features capture user activities and how the user is login and access patterns and command patterns. So selecting meaningful features require domain knowledge and careful analysis. So, weak or irrelevant features introduce noise and reduce detection accuracy, while the strong features capture essential security signals. So, in practice, the feature engineering is often thing with machine learning, which succeeds, which the security system will identify which feature is important for succeed or which feature is important for failure. Next is data pre-processing for security in machine learning. So data pre-processing, what is data pre-processing? So you'll be having raw security logs like where it has some messy noise and inconsistent data. So logs may contain missing values, duplicated entries or irrelevant information. So therefore data pre-processing is crucial step before applying machine learning techniques. So cleaning the data ensures that errors and inconsistencies which do not mislead to the model. So another major challenge in security data is class imbalance. In most data sets, normal events vastly outnumber attack events. If this imbalance is not addressed, the model may learn to classify everything as normal. So techniques like cost techniques such as resampling, synthetic data generation, and cost sensitive learning are used to handle this issue. So normalization and dimensionality reductions are also important, and normalization ensures the features are comparable scales, while dimensional reduction ensures like reduced computational complexity. So proper pre-processing lays the foundational to accurate and reliable security ML features. So next is attack detection techniques using machine learning. Machine learning enables a shift from traditional signature based detection to behavioral based detection. So signature based systems rely on known patterns or attacks and which will fail to new attack variants. ML based systems on the other hand analyze behavior and identify suspicious activities based on learning patterns. Anomaly detection identifies deviations from normal behavior. Pattern recognition identifies recurring malicious activities, and statistical modeling estimates the probability of an event being attacked. So, these techniques allow Security systems to detect subtle the complex threats that would otherwise unnoticed. So by continuously learning from new data, ML based detection systems remain adaptive and resilient. This adaptability is essential in modern networks where where you will be getting the rapid and predictable attack patterns will be easily detected. And how you will do model training, testing and validation. So training, testing and validations are needed in building a trustworthy machine learning. So training, the model learns patterns from historical data, like you are training, and testing means the model's performance or unseen data to ensure that it generalizes well beyond the training set. So cross validation is often used to improve reliability by training and testing the model on different subsets of the data. So outfitting occurs when the model memorizes the training data instead of learning general patterns. So while underfitting occurs when the model fails to capture important relationships. Proper validation ensures that security models perform consistently in real world environments. A poorly validated model may provide false sense of security, which can be more dangerous than having no model at all. Okay, so it should be properly generalized. So what are the evaluation metrics in machine learning? The evaluation metrics in machine learning for cyber security is carefully analyzed. Like accuracy alone is not enough, so it may mislead you to because of the instances are rare compared to normal events. A model that classifies everything as normal may achieve high accuracy but fail to detect attacks. So precision measures how many detected attacks are actually malicious, while recall measures how many real attacks were successfully detected. The F1 score also balances between precision and recall, which provides more realistic assessment. So false positive can overwhelm security terms, while false negatives allows attack to succeed. So the AUC evaluates a trade-off between detection rate, false alarms across different thresholds. So you have to choose the evaluation metrics in critical manner to build the trustworthy security solutions. So next we will discuss on concept drift in cybersecurity. So, what is concept drift? It is a change in underlying data patterns over the time. In cybersecurity, the attackers constantly modify the techniques to evade the detection. So, as a result, patterns learned by machine learning models may become outdated. So, if models are not updated, their detection accuracy gradually declines. So, to address concept drift, the security systems must support continuous monitoring, periodic retraining, and adaptive learning strategies. Handling that concept drift is essential for maintaining long term effectiveness of ML based security solutions. And adversarial attacks. So it is an new things like machine learning models themselves can become targets of attacks. So adversarial attacks means manipulate the model's behavior by exploiting its weakness. So data poisoning attack introduce malicious data in the training process, causing the normal model to learn incorrect patterns. So evasion attacks craft inputs that appear benign to the model while being malicious in reality. So, model inversion and extraction attacks aim to steal sensitive information or replicate the model. So, these threats highlight the need to secure robust and explainable machine learning models in cybersecurity. So, finally, what you understood from this thing is, so machine learnings are very important for cybersecurity, which enables intelligence, adaptive things, and scalable for communications. But it depends on data quality and feature engineering, continuous learning, and secure deployments. As the attackers increasingly adopt to AI driven techniques, the future cyber defense systems must evolve to become resilient, transparent, and trustworthy. I hope you understand the necessity of machine learning in cybersecurity. So, soon we will meet with the next lecture. Thank you.